Welcome to This Explainer. Today, we're unpacking a seriously high-stakes engineering mystery straight out of the EQA Petrochemical Company's Value Engineering module. We're going to look at one of the most, fascinating phenomena in project management, how highly skilled professionals can look at the exact same problem with the exact same constraints and literally walk away with completely different realities. We are talking about the massive difference between settling for a minor, everyday discount and unlocking a truly optimized engineering breakthrough.
Okay, let's dive into this. Picture a sliding door scenario for a second. We have two teams. Both teams are handed the exact same engineering scope. They're put in the exact same room, given the exact same 3-day timeline, and they have access to the exact same information. And yet at the end of day 3, their presentations are just worlds apart. One team walks out having negotiated a small, conventional discount on a piece of equipment, but the other team? They walk out with a genuinely different, thoroughly optimized engineering redesign that dramatically improves the project's bottom line, without sacrificing even a drop of performance.
So what made the exact same resources yield completely different engineering outcomes? That right there is the central question of our explainer today. What single choice separated an adequate outcome from an exceptional one? Because, it wasn't raw intelligence, it definitely wasn't the budget, and it absolutely wasn't luck. The dividing line came down to one thing: process discipline. Specifically, how each team navigated the value engineering job plan. To understand exactly where things go right and where they so often go wrong, we need to look at the specific challenge these two teams were facing.
Here is the concrete industrial problem both teams had to tackle. They needed to debottleneck a feed preheat train on an ethylene cracking unit, which is also known as an olefins unit. This is heavy, complex petrochemical work. The stakes are high, and the capital costs even higher. Both teams needed to find a way to fundamentally improve the value of this system. So how did they approach it? Let's start by looking at our first group.
Part 1. Team A, the creative trap. So Team A, they're a really smart group, right? But they fell headfirst into the single most common failure mode in value engineering. They rushed. Just look at their timeline. They spent exactly 20 minutes, yes, literally just 20 minutes reviewing the current design of the preheat train. Then, on day 1, they jumped straight into brainstorming. And because they completely skipped the sequence discipline, they had no objective baseline. By day 3, they were totally time-blind. They were in this intense debate over vendor discounts on a design that was completely unchanged and drastically overspecified. They were essentially haggling over the price of the wrong solution. Which brings up a really crucial rule from our source material. The loudest voice in the room does not equal the highest cost function. Because Team A skipped that foundational analysis, their brainstorming naturally just drifted toward whatever component the loudest person in the room wanted to talk about. Their ideas targeted parts, things like replace the valve or change the exchanger, instead of targeting functions. They argued opinions instead of comparing actual numbers. And because of that, the real savings simply never got targeted.
Part 2. Team B, function first. Now, what's really interesting about this slide is how we pivot to a radically different, disciplined methodology. While Team A was practically sprinting to the whiteboard on day 1, Team B hit the brakes. They employed a highly disciplined methodology starting right with Phase 2 of the job plan, function analysis. This right here is what distinguishes true value engineering from just another simple cost-cutting meeting. Team B actually paused to name exactly what the design must do, strictly using a 2-word verb plus noun format. Stripping away the specific parts, they define the core function simply as transfer heat. This kind of linguistic discipline forced the team to build a shared objective baseline before a single alternative was even proposed.
Team B followed a very deliberate, structured sequence. Step 1, map the fast diagram. Step 2, calculate the cost-worth gap. And Step 3, target the unwanted secondary function. This sequence definitively proves that discipline in your process is far more powerful than raw, unstructured creativity. Let's see how this actually translates into one of the most powerful visual tools in project engineering.
So let me introduce you to Team B's secret weapon, the FAST diagram, which stands for Function Analysis System Technique. Developed way back in 1964, this is a visual map that arranges functions by logical dependency. It asks how and why, rather than looking at the chronological order the work happens in. By doing this, Team B clearly separated the basic function, which again was transfer heat, from all the other secondary functions, like meet code or reduce fouling. They essentially mapped out the entire DNA of the project's purpose.
So the crucial point is how Team B actually applied numbers to this map. They calculated the value index for every single function, and the formula is beautifully simple. Value index equals worth divided by cost. Worth is the cheapest reliable way to perform a given function, and cost is what the current design actually spends to deliver it. If your value index is below 1, it means you're paying more than the function is actually worth. This acts like a massive spotlight, pointing the team exactly to where their creative energy should be spent.
And this is where we hit an incredible narrative climax for Team B. When they calculated that gap, they made a massive discovery. The basic function, transfer heat, was actually fine. If they had brainstormed ways to change the heat transfer like Team A did, they would have completely wasted their time. Instead, they found that the real cost issue was hiding in one specific secondary function: fouling-related maintenance access. The current design was literally hemorrhaging money just to allow operators to clean it.
Part 3. The winning sequence.
And this brilliantly illustrates the massive divergence in their final presentations. By having the discipline to wait, Team B found the exact target they needed to hit. Because they aimed their entire creative phase directly at that single secondary function, the outcomes were just night and day. Team A, who rushed, walked away having negotiated a small price discount on an unchanged, overspecified part. But Team B, they produced a genuinely different, optimized engineering design. They solved the fouling maintenance issue fundamentally, which saved massive amounts of lifecycle cost.
Which brings us to the overarching lesson of this entire module. Value engineering protects function while lowering lifecycle cost. I can't emphasize this enough. It is not just cost-cutting. If quality, performance, or reliability drops just to save a few bucks, you aren't doing value engineering. You are just cutting scope. True VE, exactly like Team B demonstrated, is all about optimizing the function-to-cost ratio. It's about looking at the entire lifecycle of the asset, not just haggling for a cheaper part on day one.
So when you skip the function analysis phase, you aren't actually engineering anything. You're just shopping for a cheaper version of a potentially flawed design. The next time you sit down in a project room with your team, eager to jump straight to the whiteboard to solve a problem, pause. Look at the sequence. Ask yourself, are you truly engineering value, or are you just value shopping? Thanks for joining me for this explainer, and I will see you next time.